Hello students, let's look at redox reaction. Redox simply stands for reduction and oxidation. So it is a reaction in which both oxidation and reduction takes place. So let's look at what is oxidation and what is reduction. Oxidation is simply the increase in oxidation number. So increase in oxidation number, and then reduction is the opposite, decrease in oxidation number. Oxidation can also be defined as adding oxygen chemically to a compound, and reduction can be defined as removing oxygen chemically from a compound. Oxidation can also be defined as the removal of hydrogen or the loss of electrons, and reduction will be the addition of hydrogen or gain of electrons. But what you can use to assess whether oxidation or reduction is taking place is the oxidation number, increase in oxidation number, decrease in oxidation number. So let's see how we can find oxidation numbers, and then we proceed to see how we can balance redox reactions. So we want to know how to assign oxidation number. So there are some basic rules you must know so that you can assign oxidation numbers. First of all, if this is an atom, we will write the oxidation number here, the charge of the atom, either positive or negative. And then this is the frequency of the atom. So this is where the atomic number is, this is where the mass number is. But let's focus on this. So if I have Br2, meaning I'm having two atoms of bromine. If I have Br and I put 2 here, the frequency here is 1. So I'm still having two atoms. If I put 2 behind here, I'll end up getting 4 atoms because 2 by 2 is multiplying the frequency. So take note of this. We'll be using it when we are balancing redox reactions. This is where you put the charge. So the rules you have to know is that if you have molecule, a neutral molecule or compound, then the oxidation number is going to be 0. So something like H2O, this is neutral, this is completely neutral. So the oxidation number is what? 0. We are not seeing any charge on top of it. If you have an ion or radical, then the oxidation number is going to be the charge of what? That ion or the radical. So if you have SO4 2 minus, the total oxidation number is called what? Negative 2. If you have Fe2 plus, the total oxidation number is what? Positive 2. So take note of that. Now, there are some particular atoms, the oxidation numbers are fixed, like group 1 atoms. So group 1, group 2, and group 3 atoms. They have oxidation states of +1, +2, and +3 respectively. So you'll be seeing them. And there are lots more. There are lots more. So they have a fixed oxidation state. So group 1, group 2, and group 3, they have fixed oxidation states. Now there are a lot of exceptions, but then let's just go straight to the point. Okay, if you know how to get oxidation number, it's very simple. So something like hydrogen and oxygen. Hydrogen, in most cases, the oxidation state of hydrogen is also +1 because it can be found in group 1. Sometimes it can be found in group 7, so there are some few exceptions. But if you forget the exceptions, you can still calculate for the oxidation number manually. So for hydrogen, it has oxidation state of +1 in almost all cases. So almost means there are some few exceptions. If I give you something like lithium hydride, you see now hydrogen is acting as what? A non-metal here or an anion. So it's not going to take the +1, but you will know how to calculate it. If I give you something like um, this calcium hydride. The oxidation state of hydrogen here will not be the same. So we'll come and look at how to calculate oxidation state using these simple rules. Now, oxygen has oxidation state of -2 in almost all cases. So there are some few exceptions here. Okay, so if you see something like this is a peroxide. If you see something like this, hydrogen peroxide to be precise. If you see something like this is a superoxide. So the oxidation state of oxygen in peroxides and superoxides will be different from what? The -2. So now let's fill up all the fixed rules so that anytime we are giving a compound or a molecule, we can find the oxidation state of anything at all. So we know oxygen has oxidation state of -2 in almost all cases. Hydrogen has +1 in almost all cases. This group 1, group 2, and group 3 elements or atoms, the oxidation states are also fixed. Oxygen is from group 6, so if you see an atom from group 6, we expect that it should also have -2, something like sulfur. Okay, now the group 7 elements, the halogens, fluorine, chlorine, bromine, iodine, these guys too, their oxidation state is mostly -1. There are some few exceptions too, but don't worry. So now that we know these rules, we can find oxidation number. So proceed and know how to balance redox reactions. But let's take some few examples from here. Let's find the oxidation states of the underlined atoms. So want to find the oxidation state here. Remember we spoke about frequency and charge. So here, what's the frequency of the nitrogen atom? Is 1. Okay. So if we let Y be the oxidation state of nitrogen in this whole molecule, then how many times, what's the frequency of nitrogen? How many nitrogen atoms are here? 1. So 1 times the oxidation state of nitrogen, Y, plus oxygen. How many atoms of oxygen here? What's the frequency? 1. What's the charge of or oxidation state of oxygen? Almost all cases, is -2. So we've added the oxidation state of nitrogen plus the oxidation state of oxygen. So the total should equal to the total oxidation state of the whole molecule. And since there's no charge written here, it's equal to 0. Remember we said that what? For a neutral molecule, the oxidation state is 0. Neutral means we are not seeing anything written on top of it. We are not seeing the charge. So let's proceed. So y minus 2 equals 0. So y equals +2. So the oxidation state of nitrogen here is +2. Let's proceed. How about N2O? So here we know that 2y plus 1 multiplying, because there's one oxygen atom, -2 equals 0. -2 because oxygen has -2 in almost all cases. So 2y minus 2 equals 0. 2y equals 2. Y equals +1. You see? Then the very last example, MnO4 minus. So here we have to find this. The manganese came once, so 1 times Y plus 4 times oxygen should give us -1. The total charge is -1. Y minus 8 equals -1. Y equals -1 plus 8. So Y equals +7. The oxidation state of manganese is +7. Now we can find oxidation number. So now let's proceed and see how we can balance redox reactions. So this is an example of a redox reaction, Cu2 plus Zn going to Cu plus Zn2 plus. Alright, so we said oxidation is an increase in oxidation number and then reduction is decrease in oxidation number. If you take Cu, the oxidation state here is +2. At the reactant side, at the product side, the oxidation state is 0. We are not seeing anything there, any charge there. If you take zinc, the oxidation state here is 0. On the product side is +2. So copper has what? In, the oxidation state of copper has been reduced from +2 to 0, and that of zinc has been increased from 0 to what? +2. So what is the inference here? The inference is that copper has undergone what? Reduction, decrease in oxidation number, zinc has undergone oxidation, increase in oxidation number. So we call something oxidizing agent, or you can call it oxidant. So it is anything that any species that undergoes reduction. Take note of that. It undergoes reduction because in the process of oxidizing somebody, it is being reduced. And we have reducing agents or reductant. So it's what undergoes oxidation. In the process of reducing someone, another species, it is being what? Oxidized. So what's our oxidizing agent? The species that has undergone what? Reduction. So our oxidizing agent is what? Cu2 plus. Our reducing agent is Zn because it has undergone oxidation. Now let's see how we can balance redox reactions. So okay, before I proceed, if you look at this, you can write an equation for what? The oxidation process. So the oxidation process is what? Zn going to what? Zn2 plus. And then the reduction process is what? Cu2 plus going to Cu. So this is what? Oxidation half, reduction half. Okay, I haven't balanced this. We have to balance. I've not balanced it, so I'm just showing you how to write the half equations. Later, we have to balance the half equations and add them to get the overall balance redox reaction. So that's what we are going to look at right now. So balancing redox reactions. So there are a few rules here. Rule one: before you balance, check the medium. Check the medium, whether it's acidic medium or it's basic medium. So you also have to ignore spectator ions. So spectator ions, the oxidation state both is constant throughout. And we know those guys whose oxidation states are always what? Constant. So they will exist as what? Spectator ions. Both in the reactant and product side, the oxidation state is the same. So we just cancel them out, ignore them. Then three, get your half equations. Then four, you balance all atoms except oxygen and hydrogen. There's a special way we balance oxygen and hydrogen here. And that's why I say first, before you start, check the medium. So the medium will show us how to balance the oxygen and the hydrogen, whether it's acidic medium or basic medium. So after you balance all atoms except oxygen and hydrogen, then you can proceed to what? Balance oxygen and hydrogen depending on the medium. Then finally, you balance the charges. So after balancing the charges, then you make sure that charges are what? Same for both half equations. For both half equations, then you can then what? Add the half equations. These are the rules. So simple. So now let's proceed and balance. We have Cr2O72 minus plus Fe2 plus going to Cr3 plus Fe3 plus. This is our equation we want to balance. So first of all, we have to identify which species was undergoing oxidation, which species is undergoing reduction. In other words, your oxidizing agents and reducing agents. So check the Fe here, oxidation state plus 2, here plus 3. So from 2 to 3 are increasing. So we can clearly say that what Fe2 plus is a one undergoing oxidation. So these are our reducing agents, isn't it? So we can get our oxidation half. So what's our oxidation half? We have Fe2 plus. So you can leave some small space there going to Fe3 plus. We've gotten our oxidation half. And ask yourself, we have to balance all atoms, isn't it? The frequency here is 1, frequency here is 1, all atoms are balanced. There's then since we've balanced all atoms, I didn't specify the medium, so let's balance this in acidic medium, okay? I've specified that we should balance it in acidic medium. Sometimes you'll not be told, but if you see H plus there, you know it's acidic. If you see OH minus, you know it's basic. All right, so now since the atoms, the ion atoms are already balanced, the frequency here is 1, frequency here is 1, and then there's no oxygen atom there, so, and there's no hydrogen as well. If there's no oxygen, there won't be hydrogen as well because we balance oxygen first before we can balance the hydrogen. So since all atoms are already balanced, then we skip oxygen and hydrogen because they are not here. Then we have to balance the charges. The total charge here is what? You see the number, the moles must multiply the charge, so 1 by 2. So we have plus 2 here. Over here we have 1 by 3, we have what? Plus 3. We have to make sure the charge is the same at both sides. So we use electrons to balance the charges. And electrons are negatively charged. So how can I make sure both sides are equal? If I just do minus 1 here, I'm going to get what? Plus 2, meaning the minus 1 is what? 1 mole of an electron. So here plus 1 mole of an electron. So 3 minus 1, 2. Here is also 2. Then balanced. Charge is the same on both sides. Now, our reduction half, we have, we can check it out. Let's see, chromium here is plus 3. Let's check the oxidation state of chromium here. This is going to give us 2y plus 7 multiplying minus 2 equals negative 2. 2y plus 7 times the oxidation state of oxygen. So we add them to get the total oxidation state of the whole compound. So 2y minus 14 equals minus 2. 2y equals 14 minus 2. 2y equals 12. Y equals plus 6. So from plus 6 to plus 3, it has undergone reduction. The species that undergoes reduction is our oxidizing agent. So we have Cr2O7 2 minus, we leave some space, right? Going to Cr3 plus. We have to balance all atoms first, except oxygen. Frequency here is 1, frequency here is 2. So you must make sure you put 2 here so that we have what? 2 atoms of what? Chromium on both sides. After that, we can balance oxygen. It's acidic medium. In acidic medium, we use water to balance oxygen. So we use water to balance oxygen. In both medium, we are going to use water to balance oxygen, okay? Yeah, so use water to balance oxygen. Which side is in low concentration of oxygen? Here we have 7 oxygen atoms. Here there is no oxygen. So here 0 oxygen atoms, 7 oxygen atoms. So here is deficient in oxygen. So we add water toward the side that is deficient in oxygen. So we know that water is H2O, and in water we have 1 atom of what? Oxygen. But we need 7 atoms of what? Oxygen on this side as well. We got here 0 atoms of oxygen, 7 atoms of oxygen. The difference is obviously 7. 7 minus 0 is 7. So we have to multiply this by 7 so that we can get 7 atoms of oxygen. So here plus 7 moles of H2O. After we've balanced oxygen, you can see 7 atoms. 7 atoms. The water we added has also introduced hydrogen. So 7 by 2, 14. So you have to add 14 moles of H plus to this side. So now oxygen, hydrogen balance. We have to balance the charges, isn't it? 1 by negative 2. We have negative 2. 14 times positive 1. So plus 14. Here we have what? Plus 12. 2 by positive 3 plus 6 plus 7 by 0. So we get what? Plus 6. We have to make sure that the oscillation state, the charge is the same on both sides. So here we have plus 12, here we have plus 6. So which side should we introduce negative so that it will be equal? We have to introduce negative 6 here. If we do minus 6 here, we are going to get plus 6. And here so plus 6. In other words, we are going to add 6 moles of electrons here. We balance the electrons to the charge. Alright, now We have to add these two, but before we can add them, we have to make sure that the number of electrons are the same throughout. Here we have 6 moles of electrons, here we have 1 mole of electron. So all we have to do is that we multiply the oxidation half by 6, so that we can have what, 6 moles of electron here too. So multiplying through by 6, we get this, isn't it? So after multiplying through by 6, we get, and then we can proceed to add them. If you are adding, things which are on opposite sides must cancel out. So this means that 6 moles of electrons on the right hand side will cancel out 6 moles of electrons on the product side. There's nothing here in common. There's nothing here in common. We can proceed and add the two balanced half equations to get the overall balanced equation. So our overall balanced redox equation is this: plus 14H plus going to 6 moles of Fe3 plus 2 moles of Cr3 plus 7 moles of H2O. This is our overall balance equation. This is how you balance in acidic medium. But what if you are asked to balance in basic medium? If you are asked to balance in basic medium, you do the same thing, okay? You do the same thing. So if you are asked to balance in basic medium, you basically do the same thing. But when you are done, you are going to add what? OH minus to both sides of the equation. The OH minus we are adding, you check the H plus, you know that OH minus plus H plus is going to give us water, isn't it? Neutralization reaction. So now we are going to add OH minus to both sides. If we are asked to balance in basic medium, here we have 14H plus. So all we have to do is that we add 14 OH minus to both sides. We've done that. Then this is going to give us water. So we have 6Fe2 plus Cr2O72 minus plus 14H2O going to 6Fe3 plus 2Cr3 plus 7H2O plus 14OH minus. Now we're having 14H2 here, we're having 7H2 here, and we said that if the same thing are on opposite sides, they cancel. So the 7H2 will come and cancel out this, so that we will be left with what? 7H2. 7 will cancel out 7 here, and here is 14, so remaining 7. So our balance redox reaction in basic medium is going to be this. So plus 7H2O going to 6Fe3 plus 2Cr3 plus 14OH minus. So this is a balanced redox reaction in basic medium. This is a balanced redox reaction in what? Acidic medium. So that's the only difference. Alright, let's look at this question. It takes 38.29 milliliters of a permanganate solution to titrate 0.2587 grams of primary standard. They give us the molar mass and what is the molarity of the permanganate. And here they balance the redox reaction for us. So we have to find the molarity, which is the concentration of what? The permanganate. This is the permanganate. So let's see what we have to do. We're given the volume of the permanganate solution, and we're given the mass of the primary standard, and we're given the molar mass of the primary standard. So we can find the moles of the primary standard. So moles of the C2O4 2 minus should give us what? Mass over molar mass. So the mass is 0.2587 over 133.999, and that should give us 1.931 by 10 to the power minus 3 mole. We've gotten the mole of our primary standard. So since we have the mass and the volume of the permanganate, we can use mole ratio to find the actual mole of the permanganate, then we divide by the volume to get the molarity. So mole of the permanganate from the balanced redox reaction over mole of the primary standard should be equal to 2 over 5, the ratio. So we can make this one the subject. Mole of the permanganate should be equal to 2 over 5 times the mole of our primary standard. So that's going to give us 2 over 5 by 1.931 by 10 to the power minus 3. We are going to get something like 7.724 by 10 to the power minus 4 mole. Now that we know the mole of our permanganate and we are given the volume already, then we can find the concentration. No concentration is mole over volume, mole per liter, but our volume was giving us a milliliter, so we have to convert it to what? Liters. So concentration of the permanganate should be equal to the mole we found using our mole ratio divided by the volume. But the volume is 38.29 milliliter. 38.29 milli is 10 to the power minus 3. Then this is going to give us 0.02017 mole per liter. So we are applying redox over here. Now, in some questions, you'll not be given the balance equation. You have to balance it yourself and do the calculations. So, looking at this question like this, the amount of Zn in impure sample of the metal ore can be determined by titrating a sample of the ore with a potassium bromated solution. So if 2.850 gram of the ore consume 20.50 milliliter of a 0.250 molar KBrO3 solution, calculate the percent zinc in the sample. Assume BrO3 minus ion is converted to Br2 and Zn is converted to Zn2 plus in the reaction, and they give us the molar mass of the Zn. So here you have to balance the redox reaction yourself. So we know that Zn was converted to Zn2 plus. So this is oxidation because 0, 2 plus 2 increase in oxidation number. And over here we have BrO3 minus going to Br2. The oxidation state of the Br here is what? 0. Charge is 0. Here we can get it y plus 3 times negative 2 equals minus 1. Y minus 6 equals minus 1. Y equals 6 minus 1. Y is equals plus 5. So from plus 5 to 0, that's reduction. Then you are going to balance it. So in this case, you can choose to balance it in either in acidic medium or basic medium because you are still going to get the same mole ratio. You balance this and you get something like this. When you get your balance equation, then you have to get your mole ratio. But mind you, they give the concentration and the volume. The volume was given here. This was the volume and the concentration of this, the BrO3 minus. You can use that to find the moles. When you find the moles, use your balance mole ratio to get the mole of the zinc. After getting a mole of the zinc, um, you can find the mass of the zinc because we're given the molar mass of the zinc. You know that mass is what? Moles times molar mass. After getting the mass of the zinc, then that mass of the zinc over the mass of the ore times 100% should give you the percent zinc. So the percent zinc is 41.16%. Solve it and see if you will get the same answer based on the explanation I gave. I wish you the very best in your exams.